balance for some of it, okay? Make sure when you get the test that you're reading the, what I am asking you to do, read that carefully, because sometimes I'm just going to be asking you to translate, and then you need to be doing things like ionic compounds. You need to make those neutral, okay? So today, for lab, we need the 5 types of reactions. Tony, what's one type of reaction we need? Double replacement. Okay. And remember that on the test you were going to be asked to identify identify what type of reactions this is. So remember that for double replacement you're getting a compound plus a compound. Okay, and then you're making a new to new compounds. Okay, so that should be what you're doing to recognize it. Nick, what's another one? Type of reaction.
Synthesis.
Okay, synthesis. All right, to recognize synthesis. Riley, do you remember what we need to, if we're doing synthesis, do you remember what we have as our reactants?
Oh, the
You're very close. We do want 2 things, and they're going to combine to make one thing, but they don't have to be a metal and a non-metal. They could just be 2 elements. So you were really close. So element plus an element, okay? And then we're going to be making one new product, okay? So only one new thing. Addie, can you tell me a third one? Okay, decomposition. And for that, what are we starting with? It's usually a compound, just one thing, right? Just one thing as our reactant. So these are all on the reactant side of the arrow, okay? Jonas, tell me a 4th one. Say it a little louder.
Combustion.
Combustion, yeah. Okay, so for combustion, what do we have to have, Selena, as one of our reactants? We're burning stuff, so what do we have to have? We have to have a compound, okay, so we're going to have a compound, and then it's going to be, when we're combusting, we are burning stuff, we're consuming something. Oxygen, there we go. So this is a key indicator to us. We have to have oxygen as one of our reactants, okay? So when, especially if it's burning, is combustion. Justice, you got the 5th one? Single replacement, nice. Okay. Maynard, how are we going to recognize single replacement? What are we going to have on our reactant side?
CE.
Yeah, so a compound plus an element. Remember that our element is key here for determining what we're replacing. Like replaces like. This single replacement, this is the special one that needs that activity series, where if you're predicting whether it can happen or not, that element that's trying to replace either the metal or the non-metal, whichever kind of thing the element is, that has to be more active to be able to make that reaction go, okay? So these are the 5 types of reactions, and then in this lab, the only one that we're not doing is synthesis, okay? So you will be identifying, on the last page, you'll be identifying which type of reaction it is, but we're not doing synthesis. All right, so on the back page, you see how there are different station letters, A through F. Those are corresponding to the different stations in the lab area. And you're going to be doing these reactions. So you could just look, right now, I don't want you to fill it all in, but you could look at what type of reaction that is going to be. So the right-hand column says what type of reaction was observed. Well, it's going to be one of those 5 types, right? And we have to be able to recognize the 5 types and tell which one is which, okay? Notice that in these reactions I gave you things like if it's going to form a solid, if it's going to be aqueous, if it's going to form a gas. If we're forming a gas, Blessing, what are we looking for in that reaction if we're forming a gas? Forming a gas, what kind of thing are we going to see? Well, okay, can you see oxygen being formed? But could you observe something in the solution, maybe, that's telling us that a gas is being formed? Okay, what would you see about the gas in a solution? Like, let's say you just have a liquid. and you're forming gas, what are you gonna see? It's doing something. Okay, you might see some vapor. Okay, so if it's combusting, that's okay. So maybe you made a gas that is going to start on fire or something. Nick, you want to help blessing out?
Condensation.
Okay, you might see condensation if you're forming water vapor. If you're forming a gas, like as a chemical reaction, you're forming a gas, what are you going to be observing? Bubbling, yes, that's what I'm looking for. You're gonna see a lot of that, like fizzing, bubbling, right? You're going to be seeing a lot of that as an indication, right? We've talked about this before, an indication that we have a chemical reaction going on, okay? Make sure you're sitting right next to Sebastian so you can look at the lab together, like right next to him. Yeah, well, that's just taking the lab. Just, you guys are sharing the lab. Okay. All right, so these are the reactions you were doing, okay? Eye protection is an absolute must because you're working with some things like concentrated hydrochloric acid, okay? And I'll go through that again. But eyewear is a must. If you take your eyewear off, am I going to let you stay in the lab?
No.
Absolutely not. You are going to be kicked out of the lab and it's a 0 for the lab. So are you allowed to take your glasses off at all?
No.
No. Not even for a break. If you need a break, get out of the lab area, take your goggles off, then come back into the lab area with your goggles on, right? 100%. Yesterday I had to send somebody out of the lab area because they took their goggles off. Not okay with me. Concentrated hydrochloric acid will cause you extreme eye damage. Okay. All right. Everyone, I believe I checked everyone has closed-toed shoes. My people with long hair must have their hair back and hair tied. Thank you, Tony. I see a lot of you already took care of that. Okay. One of the stations we are not going to do in person because, Raylan, stay with me, because it could actually cause you eye damage just by looking at it. So turn to F, like if you're not already there. Look at F. Okay. We are taking magnesium solid and reacting it with O2. So Sebastian, what kind of reaction is that? We are using O2 as a reactant. It's going to be a combustion. We're burning it, okay? So we're going to burn some magnesium and we're going to make what? Diego, what is our product?
Like here people go?
Okay, we're on station F.
Yeah, no.
What's our product?
Oh, MgO.
MgO, magnesium oxide, is going to be our product, and it is a solid, okay? During this combustion, an intense light is given off, and that's why we're not doing it in person, because the light, if you look at the light, it can actually damage your eyes just like staring at the sun can. So that's why we're going to watch a video of this. But I want you, I know it's sad, but I don't want you to lose your eyesight, okay? So we're going to watch a video of it so that you can still make some observations. I still want you to write some observations here for station F, okay? Everybody clear on why we're watching this instead of doing the person? I definitely don't want to cause any long-term eye problems. So see, the little piece of metal here is what? What are we burning? Magnesium. So, and what color is it? Kind of a silvery color, okay? Remember that color changes are also indications of chemical reactions. Okay? All right. So there's no narration or anything. It's just they're going to start on fire. Like I said, this light that's being off, it's fine to watch it in the video, but in real life, it actually could cause eye damage if you look at it. Okay, so reaction is over. What did you observe? What did you write down in your observations? What happened during the reaction?
Light.
Station. It caught on fire, so we were combusting it. Okay, so Blessing is saying we saw color change. We had it was silvery, it burned, and now we have white. So Jasmine, what is this product that we made that's white? Magnesium oxide, okay. So we have a color change because we did do a chemical reaction. Okay. In your observations, you might also want to say bright light. Now, we don't know because we didn't feel it, but probably heat was probably given off during that as well. It sure looked like it got hot. Okay. So those would be types of observations that I'd be looking for. When you're at the different stations, I want you to be telling me, did you observe bubbling? Because that would be indicating you formed a gas. Did you see a color change? What things happened to indicate that you actually had a chemical reaction? Okay? Right.
Well, what type of reaction was observed?
So the 5 types of reactions that I just had on the board? Yeah. So which type of reaction did you have? And again, looking at your reactants should be a huge indicator there as to what type of reaction you have. All right, so in the lab area, eye protection, yes. Okay. All right, go ahead and turn over here so I can kind of give you some hints on things. Addie. All right, so at this station D, take a look at what reaction you're going to be doing. Check, what reaction are we doing in station D? Are we? Station D? There's one thing. Okay, well, tell me. What there? For station D, what are we doing?
Yeah.
Okay, we have one thing.
Oh, single phase.
One thing in our reactants. Only one thing. There's only one reactant. What type of reaction did we just talk about that has one thing? Only one thing. I took it off the board already. Okay, this is why we went over these types of reactions right before. It would be decomposition. Thank you, Riley. Okay, check. What is it? Decomposition, one thing. Okay, now take a look in this equation. We have this little MnO2 over the arrow. You see that? What did we talk about? Kylan, what is that indicating if it's over the arrow? You remember what that's called when we have it over the arrow? We talked about this day 1 notes. Starts with a C. Oh, Harris, do you remember? Oh, Blessing, do you remember?
Is it catalyst?
Good, it's a catalyst, okay? So, the MnO2 is a catalyst. It is not a reactant. So that is why it is not included on the reactants, and you do not need to worry about it when you're balancing your equation, okay? A catalyst is there to help speed up your reaction, because if all I did was had my hydrogen peroxide there, it will eventually decompose, but it might take a couple years. I don't have that time, right? So we're going to add the catalyst, we're going to add the catalyst so that it happens within our lab time, right? So this little beaker here has just a little bit of the catalyst, because all you need is a little bit of the catalyst, all right? You do not need a tremendous amount. You have a graduated cylinder to measure out your hydrogen peroxide, and then you're going to be doing your reaction in a beaker, okay? So measure out the hydrogen peroxide and put it in the beaker, add a little bit of the catalyst, observe the reaction. When you're done, swirl it, dump it into my waste beaker, use a paper towel to wipe out the beaker so it's ready for next week. Okay, questions about that? Okay, make sure you're writing down observations. This one, if you don't know how to use a lighter, I'm going to give a quick demonstration because some people don't know. In the instructions, I think it says use matches and douse it with water. Don't do that. Just use the lighter. You're going to blow out the candle. You can choose any of these candles to light to observe this. Okay, on these lighters, usually there's like a little safety kind of thing. So you kind of use your thumb. Check, are you looking? So you know how to do this? Yeah. Okay, so just push this forward a little bit and down, and then you can trigger, okay? If you just try to push the trigger without doing the safety, it's not gonna work, right? Everybody see that? Some people don't know how to use a lighter, it's okay. All right, station C. All right, take a look at what reaction we're doing in station C. What are we doing? Jasmine, what are we doing? Station C. Single replacement. We got some magnesium metal strips, just like they did in the video for burning, except we're not burning it, okay? I have a bunch of test tubes. Obviously, turn the test tube right side up. I just washed them last night. You're going to be using concentrated hydrochloric acid. So Jonas, you might want to wear gloves, right? Concentrated hydrochloric acid. You don't have to, but it's probably not a bad idea to use your gloves for this station, okay? Okay, so single replacement reaction. Then we have station B. Take a look at what station B is. Tony, what type of reaction is station B? Double replacement. We have two aqueous solutions. Remember going through our solubility notes, right? And predicting which one's going to form the solid. Only you don't even have to predict, because Justice, look at station B and tell me which product is going to form the solid. Which one says it's going to form the solid? Looking at station B. Say it a little louder. Yeah, the silver chloride. So AgCl says it's going to form the solid. So when you put these two aqueous solutions together, Diego, what should we be observing? One's going to form a solid, so what are you going to see in the two? You're going to see something form a solid, right?
Yeah.
Remember what we called that? When something comes out of solution, it's your little fun teenage term right now. It's crashing out. Thank you. It's crashing out. All right, station A. This gets a little bit tricky. Do not change the lens magnification, okay? Just leave it as it is. I'm going to turn it on so that you can actually see. You're going to be doing a reaction in a petri dish, okay? Selena, what type of reaction is this? Station A. We got our little metal strips. Got an element. Station A.
Synthesis?
Okay, I said synthesis is the one we're not going to do. So. Blessing is trying to help you out. We got single replacement because we've got an element and a compound. We've got silver nitrate. Okay, you're going to be doing this on a petri dish. I would recommend putting the copper on the petri dish. You're going to have to move the stage down a little bit so that you can see. Observe the copper by itself. Sebastian, are you with me? Observe the copper by itself. Take it back off. Add the silver nitrate and then put it back on so you can observe the changes. Okay? All right. Again, what I'm looking for, Raylan, for our indicating that we had a chemical change, I'm looking for color changes, bubbling, temperature changes. Okay? Things like that. Some of these are going to get a little bit cold or a little bit hot, depending on which reaction we did. Okay? All right, questions you guys have? All right. What has to happen before you could go into the lab area? Goggles, absolutely. Sebastian. Which type of reaction is A? Oh, E. Okay. So E is also a combustion because we're burning. Oh, yeah, and that actually is a good point. For E, look at what we're burning. The C25H52. What is that? What are we burning?
Candle.
The waxy part of the candle, that paraffin, okay? So the C22 or 25H52, that's the chemical compound, sorry. That's the chemical formula for the paraffin compound, okay? Yes, you're going to have to balance that equation. It'll be fun. Don't worry, it's not that hard. But you might want to use remember how I said before in combustion reactions, you might want to have to use a decimal and then double everything. Might be helpful for this. All right, other questions? Okay, there are only 5 stations, so we're probably going to have to take turns at the stations. When you are not working at the station, I have worksheet 6A, which is another review worksheet, where you're going to be going through identifying what type of reaction, predicting products, and then translating from word formula to chemical formula and balancing. So it's like everything, okay? And you guys have the 2 review papers that I gave you last class to practice. Those answer keys will be getting posted so that you can check your answers. Questions? Okay. Eye protection first. How about these 2 groups get eye protection and you guys can start in the lab? How about Maynard and Jonas and McHarris and Sebastian? Eye protection, start in the lab. And how about you guys do like this? And you guys will switch circling. I'll get you the review. Eye protection. This one is just practice, but if you have not finished your other review sheets, those are first.
Okay, Jake. Looking good, bro.
You
I like you.
guys can work on getting balancing on the lab together. Beautiful.
Burn it.
Very fashionable.
Bro, will you pay attention on you?
You know what it is?
Bro, no. Already not. I thought about that. I just turned it on. Okay, what do you see changing, bro? I was just thinking.
All right, guys, we cannot have 4 people in a
Totally being
group.
checked.
There's 2 people in a group.
What do you notice, Jake? Burn it.
Yeah, write down your observations. Think about what products are you
But you
forming?
might want some, just.
What are you doing? You're not on this, what are you forming? And write down some observations.
Okay. Add a 3 centimeter strip of magnesium metal. Where the hole in that
Maybe you should read the instructions all the way through. Start to finish.
bag? Add a 3 centimeter strip of magnesium, a small piece of magnesium.
You'll still be able to see. Observe what is happening, what is happening, indicating a
Smoke.
Okay, write it down.
That's pretty much okay.
You might want to do it just having it in a test tube wrap because sometimes it gets hot or something, so you might want to not have it in your hand while it's doing that.
6.
Okay. If you guys are just waiting, you could work on, either you could work on the balancing, or you could work on worksheet 6A while you're waiting for a station.
Ooh, bubbling.
You have choices. Yes, so indicating what?
Chemical reaction.
Chemical reaction, thank you. Okay. Does it seem like it might be getting hot?
Miss Sperry, is this your point?
That is just review. 6A is just review. But it's good review.
Yeah, like this. Weird smell.
So Diego, that means you should do it.
Yeah, you should do it to get ready for your
I was
test.
looking to see somebody.
We can balance like the thing.
You can work on those later. Do you guys want to switch to station
Yes.
C? Okay, Diego, do you guys want to do station C? Yes, okay, so what happens? It doesn't have to, I'm just saying, but like that would be, but, so what's happening? Did it say
Color
clear?
change, color change, color change.
Okay, we got a color change, remember we have to take this solution and put them together, what are we forming? It's a double replacement, so one of our products is crashing up solution forming that white. If you don't shake it for a while, you'll see the white kind of settling out because it's a solid. So write your observations, put your cap back on that.
Who was just speaking? Huh? Was that she?
Ready?
Yes, you are correct. And then as you guys are waiting, you can work on balancing or you can work on the review sheet. Okay, if you guys are done, you can probably switch to station D. Or, oh, you just started. Just make sure you grab a clean test tube. Just leave it to the side. I'll clean it later. Just take it off the microscope. Okay, so what did you guys see? What did it change?
No, I got it, bro. No, you did it.
At a 3 centimeter strip of magnesium, it's small.
I was like, I could see it, but I didn't see
Let me see if I can
it.
focus it so you can see what's on. That's good. Oh, yeah. You can
Wait.
Okay, look at the side of that little piece of metal. You see the crystals?
Carefully add
That's what I want
6.
you to see. And those crystals are kind of a greenish color. Okay.
Observant.
So that's what I'm hoping for. Yeah, like green crystals. So you're observing, you're thinking about what kind of products are being formed. We're burning the paraffin wax.
Yo, I see smoke.
Combusting it and forming what kinds of things. That's what I mean. It's kind of hot, and what's it doing?
It's like bubbling.
So what's it forming?
Gas. Good job.
That's not.
What is it?
You have to wait.
You guys can work on balancing your equations if you want to while you're waiting. Are you guys all set? Have you done station B?
What does it see? It's hot.
McCarris, you guys want to switch over to
Do I
station A?
wash this out or like?
No, just leave them, I'll wash them.
Temperature.
Did you guys do station C yet?
Bubbling.
Okay. Do you guys want to switch?
Oh, where did I?
You did look at already? Okay. Diego, if you can move away from the station, work on that, then maybe you'll on station. So what did you observe when you added the catalyst?
That's it.
Well, it shouldn't dissolve, right? The catalyst doesn't get you to dissolve.
Nobody.
Did you see it? Should have seen
It's essential.
So the bubbling is indicating that something is happening. What is happening? Okay, what specific type of decomposition? Okay. So as it's bubbling, what gas? We're in D. Oxygen. So we're actually producing oxygen gas, and what's my other product? Okay. All right, so when you're done observing, just scroll down, come in here, and just
Okay, what else do you see in that one?
Okay, this is not a station. You guys are just looking at So you have two compounds.
Is it just one drop?
This is a double replacement, so what is your expectation of what's gonna be formed in the aqueous solutions? There should be a solid forming package. So you should expect that as you add the two liquids together, you're gonna actually form a solid.
I think we had it.
Well, I would say probably 8 drops a week. Yes, because you want it to react together. If you put it in 2 separate. No, you're good. Just add it to the, so that they react. You should see evidence that it's
No, I think not read it.
This is a beaker, right?
You're gonna
Now we
have
have to ask.
to lower the stage, you're gonna have to lower it. You're gonna have to lower the stage to get it, and then you can raise it.
Graduated cylinder in a beaker, right?
Yes.
It was slow.
How do we know what 30 is?
On here.
So yes, that's why we measure.
It's a ladybird. That's what.
Nobody.
So do you see
Put
how
on a
much
flashlight.
Well, what's the white stuff?
Oh, wait, I see it. It's kind of foggy.
That's the white stuff, is the solid. So you put 2 clear solutions together, and it forms a white milky, right, that was solid, is white. You will wash it. All right, what station are you using? right, if you guys are done and just working on balancing, can you let them?
Skedaddle.